Assalamualaikum, brothers and sisters.
Waalaikumsalam, Doktor.
Salam, Doktor.
Salam, Doktor.
Okay, good. Everybody okay? Okay, let's
Okay.
start our day. Okay, we are going to start our class right away. Let's start our day with the recitation of Kitab Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, today we have Ustaz Muhammad Kita to lead the dua for us. Tafadhal, Ustaz.
Thank you very much, sir.
Ustaz Muhammad
Can you-
Kita.
Can you hear me?
Yes, I can hear.
Yes.
Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Allahumma nawwir bi kitabi absarana wa syahdi syudurana wa syahbihi abdarana wa khawlik bihi antinatana wa khawbihi jinanana wa syah bihi fahmina wa khawbihi azahimana wa khawlika wa khawjalika fahinlau quwata inna bik ya rahman alamin. Allahumma instahudanat wa al lam tanahu farduhudu innaha indaha jetika liheli wala nahu ya rahman alamin.
Amin ya rabbal alamin. Syukran Ustaz Muhammad Kita.
Thank you.
Good. Alhamdulillah. Okay, what are we going to do today? Let's imagine you want to venture into a business of cosmetic product made from natural resources from the tropical forest. So this cosmetic product can be sold in Europe, US, maybe Tokyo. Let's imagine we collect some, we construct some plant near in Malaysia, because Malaysia a lot of this rainforest. Let's say you develop a factory in KL, and then in Indonesia also we have a lot of forests. Say maybe in Jakarta you have another factory, and maybe you go to Brazil, also a lot of rainforest. You have another factory in Rio to produce this cosmetic product. And all this cosmetic product can be sold. You have an outlet in Europe for regional distribution in Paris, let's say. And then we have another outlet, let's say, in New York. And maybe the southern region, Sydney. And we have Tokyo or whatever. I think it's enough. So now you have this manufacturing plant in KL, and then also in Jakarta, in Rio. And all this plant can supply to regional distribution outlet in Paris, Jakarta. So from KL also can be sent to New York outlet. KL also can send to Sydney to supply the southern region, maybe to New Zealand also. Those from Jakarta also can be sent to Paris. Jakarta also can be sent to New York. And from Jakarta also can be sent to Sydney. And also from Brazil also can supply to Paris. Then the same thing can supply to New York, and then this one also can supply to Sydney. How are you going to ship all this product, brothers and sisters? By bicycle?
Sheep.
By ship. Okay, by ship. And then this supply cost, maybe in containers, you put in containers, the cost from KL, from Jakarta, and Rio is not the same to this different outlet. So if you are in business, you want to transport all this thing, you want to send all this thing. Does price matter or it doesn't matter? Maybe you ship or maybe air cargo.
Cost, price. What do you mean? Price of the shipment or price of the thing?
The price of the shipment.
Oh, of course, it matters.
It matters. So you want to have any cost will do, or you want to get the cheapest cost?
We
Cheapest
want
cost.
cheapest cost for everything.
Cheapest cost. Okay. So you are not going to send by lorry, right? You cannot reach there. So maybe by ship, sister say, or air flight, air cargo. Okay, we are now working on transportations. Okay. Transportation. Look at the topic here, transportation and assignment. But for now, we are looking into transportation only. Assignment, we deal with it later. Okay, let's look into transportation. Transportation is actually a group of this linear programming problem, but we refer this as network flow problems. So, of course, as what you say, transportation is fundamental to all companies. Transport of goods from one place to another, to warehouses, to outlets, to the whatever destination. And then all these are located at different locations. The factories may be located at different locations. And then the outlet also, or the place where you are going to send also located at different locations. This transportation was formulated by these mathematicians, Hitchcock, 1941, long ago, and Koopmans, also very long ago, before I was born. I think about 10 years before I was born. Okay. This is a case scenario in Brisbane International Airport. During the construction of the airport, they had to dredge sand from the nearby seaside. They require about 1.8 million cubic meter. And then they dredged this and transported to 26 locations. They stockpile in 26 locations. Then from this stockpile at 26 locations, then they start to bring to the airport to 35 locations at the landfill. And then it is claimed that they use this transportation model and they save about 800,000 or 0.8 million US dollar. Okay, let's look straight away to our problem. Let's look into this Lohania Steel Company. Manufactures iron pipes for shallow tube wells at three plants located in Kota Baru, Johor Bahru, and Alor. And then the monthly production is 200, 130, 220 respectively. And then these steel pipes are sent to retail outlets located in Kuantan, Malacca, and Ipoh. The company has estimated that the monthly demands from this Kuantan, Malacca, and Ipoh, 180, 170, and 200 pieces of pipes. And then the transportation costs. Transportation cost is different from one place to another. Is shown in this table. Where is it? In this table. So this is the transportation cost. KB to Kuantan, 5 ringgit. KB to Melaka, 9 ringgit per piece of pipe. KB to Ipoh, 15. JB, 5, 8, 18. Alostar, what's this AS? Alostar, right? Or Asniat? Alostar to Kuantan, 12. Alostar to Melaka, 7. Alostar to Ipoh, 18. Okay. We try to model this in this way. JB, Kota Baru, JB, Alostar, they can produce 200, 130, and 220. And then the retail outlets, the demand, the requirement is 180, Melaka 170, Ipoh 200. Okay, this is the graphical representations. Alostar, Kota Baru, Johor Bahru, these are the manufacturing place. Then the green one is the location required. Okay. So we can represent this in this format. We call this network diagram. Network diagram, you can draw whichever shape here, oval or rectangle. It is shown here on the left-hand side where it comes from. Kota Baru, Johor Bahru, Alostar. So we refer this as the source or origin. Origin. Then where it go, we refer this as the destinations, the place where it's required, destination nodes, Kuantan, Melaka, Ipoh. And then this arrow represent the direction of the supply, or we represent this as routes. We call it distribution routes or arc. Then the supply is written on the left-hand side here. The capacity, supply capacity written on the left-hand side, supply. And then the requirement or demand written on the right-hand side, 180, 170, 200. And then the unit cost to transport, unit cost per unit, that means per piece of pipe, here from Kota Baru Kuantan, 5. So the numbers at the arc here are the price per unit or the cost per unit of pipes. This is another way, one way of representing in a shipment. If there is a supply from Kuantan to other place, Kuantan to other place, Kuantan to other place, Melaka to other place, say Melaka to Muar, Melaka to another place, Ipoh to other place. If we are going to deal with that, we call that transshipment. So for our purpose, we just from one origin to one destination. You don't go to, I mean, one step. I think this is enough for you also. Another way is representing this by what you call it transportation tableau. Transportation tableau. And we tabulate in this manner. This is a table. This is a standard. This is the standard way of tabulating. Kota Baru, Johor Bahru, Alostar is the origin. Then where it go, destinations, Kuantan, Melaka, Ipoh. And then the supply is written on the right hand side. In table like this, the supply is written on the right hand side. Say Kota Baru 200, Johor Bahru 130. This is the supply capacity per month. And then the requirement in Kuantan is written at the bottom, the demand, call it demand, written here at the bottom. That means Ipoh require 200 pieces, Melaka require 170, Kuantan require 180. This number in the boxes represent the unit cost. This is the unit cost, unit cost, unit cost. And then the boxes here, here we refer this as cells, C-E-L-L, cell or routes. It means Kota Baru to Kuantan is represented by this cell, the root. Kota Baru to Melaka represented by this cell. Kota Baru to Ipoh represented by this cell, and so on. It means we want to know the quantity to be transported along this route. Which route are we going to use? Which route we are going to use such that the total cost is cheapest. In this case, we have total supply 200 plus 130 plus 220, total 550. 550, right? The same thing, total demand from Kuantan, from Melaka, from Ipoh also 550. No problem. All right. Now let's play with it. We can also use linear programming, where we use minimization, since we are minimizing costs, where the quantity will be written here x11, that means x row 1, column 1, x row 1, column 2, x row 1, column 3, x row 2, column 1, x row 2, column 2, x row 2, column 3, and x31. So we have 9 variables. So minimize 5 times x11 plus 9 times x12 plus 15 times x3 until all done. And then in terms of supply, supply must be x1, x11 plus x12 plus x13 must be less or equal to the supply capacity. When it comes to demand, demand must be exactly equal. That means x11 plus x12 plus x31 exactly equal. So if you go to formulate the linear programming, this is the formulations. Minimize. This is what I mentioned just now. This is the cost. X will be the quantity transport for the different route, x1, 11, 12, 13. And so you can solve this if you wish. And then come to the supply. Must be all less or equal to. And come to demand, exactly equal to. And then, of course, the non-negativity conditions. Okay, we try this later. For now, we are going to use this table. We are going to find what we call it heuristic solution. What's heuristic? Initial solution. We are going to find initial solution, or some use the word heuristic. Who have powerful English? What's the meaning of heuristic? A quick solution. We are trying to find a quick solution. We call it initial solution because like in Simplex, we also have initial solution. After that, we are going to find optimal solution. So in this case, we are going to find the initial solution using what we call northwest corner rule. See this compass? Northwest corner. Where's northwest? Remember your school northwest is in that direction. In that directions. Okay, in that direction. Northwest corner rule. What we are going to do is we are going to find this initial solution using northwest corner rule method by looking into these cells overall. This one, this one, this one, this one. And so we are using the Simplex tableau. Then look at the most northwest corner. Look into all these 9 cells, CELL cells, or roots. I was also roots. Which one is the most northwest corner?
KB Kuantan.
KB Kuantan. Yeah, KB Kuantan here is the most northwest. So we are going to transport. We try to select this route to transport as many units as possible. Kota Baru can supply 200. Kuantan require 180. Kuantan require 180. Kota Baru can supply 200. So how many units is the maximum can supply here?
36.
180.
180. Someone said 30 something. 180 because we have Kuantan require 180. Kota Baru can supply. The first corner is from Kota Baru. Demand Kuantan. So brother answer just now 180. Everybody agree? 180 to be transported first. 180 unit along this route.
Yes.
Yes. Yes. Okay. So let's put 180 there. Does Kuantan require any from JB? Alustar?
No.
No. Okay.
Oh.
No. So no need. So let's ignore that for the time being. It's not that we're going to forget it, you know, for the temporarily. So now look at the remaining cells. Now we look at the most northwest corner. Which one is most northwest corner?
KB
Melaka.
JB Melaka or KB Melaka?
KB Melaka.
KB Melaka. So KB Melaka is the most northwest. Now Melaka require 170. KB, just now we already supply how much? So KB, we have 180 taken out, right? Now left with
20.
20. So how much Melaka can get here?
20.
20. 20. Can KB send to other place anymore?
No.
No, cannot supply to Ipoh.
No.
Okay, now let's forget it for the time being. Now look at the remaining. At the remaining here, remaining cells. Look at the most northwest corner. Which one is the most northwest corner?
JB Melaka.
JB Melaka. Now, Melaka require 170. It already have 20. Okay. Now, JB can supply 130. So now how many units should you send from JB to Melaka? How many units?
130.
130?
Take all of them.
Yes.
130. So now JB cannot supply to Ipoh, right? Okay, now cannot supply to Ipoh. Now left with only 2 cells. Now use our logic. How many units to be filled up here? Use logic now. 20.
20.
20. How about Ipoh?
220.
220.
Oh, sorry.
200.
100.
Ipoh require 200.
Yeah.
Now Alusta already sent 20 out of the 220. How much remaining?
200.
200.
200. So this is your transportation. That means Kota Baru to Kuantan, 180 units. Kota Baru to Melaka, 20 pieces of pipe. Johor Bahru to Melaka, 130 pieces. Alor to Melaka, 20 pieces of pipe. Alor to Ipoh, 200 pieces of pipes. Now let's find the cost. How to find the cost? This is the cost. This is the piece number of units. 180 pieces of pipe. Each of them costs 5 ringgit. This one also 20 pieces. Each of them costs 9 ringgit. 130 pieces of pipe. JB to Melaka, it costs 9 ringgit per piece using this route. Alor to Melaka, 20 pieces, cost 7 ringgit per piece. Alor to Ipoh, 200 pieces, it costs 18 ringgit per piece. So what we do, just multiply the cost and then add all this. So this is the cost. Total cost, 180 times 5, 180 times 5, plus 20 times 9, 20 times 9, plus 130 times 8, 130 times 8, 20 times 7, 20 times 7, 200 times 18. So this will be your total cost of transportation using the initial method, using northwest corner rule method. Northwest corner rule. But is this the best solution or not? Because we do not know. We are going to find out maybe next class. One method done. Let's try another method. We are going to use, we call it minimum cost method or least cost method. Minimum cost method or least cost method to do the initial solution. Just to find the initial, like in Simplex, initial. But in the transportation, we have several methods to find the initial solution. We are interested now, for now, we are looking at initial solution. How to do that? Least cost method. So what we do, we look at this globally, overall, look into all these costs, look at the cost, then look at the least cost, the minimum cost. What's the minimum number here in the yellow boxes?
5.
5. Okay, now 5. We have 2 5s. If I were to use JB, this route, how many units can I transport?
130.
130. If I were to use this route, now we have 2 5. So we are going to use the route that gives you the least cost and as many units as possible. If we were to use this route, we can supply 130. How about this route, KB to Kuantan?
180.
180. Now, which one you want to choose first? Here 180, here 130.
180.
180, because cheapest, we try to put as many units as possible along this route. So 180. Kuantan require any more from JB? From Alusta?
No.
Oh,
No, no need. So, okay. Ignore for the time being. Now look at the next least cost. The next least cost 9, 15, 7. So 7. So we have to transport as many units as possible along this route. Alostar can supply 220. Melaka require 120. So 170. So how many units to transport here?
170.
170. Now you are faster. So how about KB Melaka? JB Melaka? No need. Okay, we ignore that for the time being. Now we are left with this 3. Which one is the minimum cost amongst these 3?
15.
15. So how many units are you going to transport, sister? Yeah?
20.
20. I think. Now we are left with these 2. Use our logic. Now 130, 100,
130.
130, all of them. Do you need any more? You require 200 enough? Do you get all to 200? Ipoh? Have Ipoh get? So require?
Not yet.
70.
Not yet.
50.
70,
50.
50,
more.
50. So we are done. So this is the route that we use using the least cost method. You will get this initial solution, 180, 180, Kota Baru Kuantan, 170, Alostar Melaka, Kota Baru Ipoh, 20, JB Ipoh, 130, Alostar Ipoh, 50. Then calculate the cost, and that's your cost. So it's slightly lower than what we have before. Let's look into the earlier one was 530. Okay. So done 2 methods. Let's look at another method to find initial solution. What do you call that? VAM. We call it VAM. Vogel's approximation method. Don't change any alphabet, brother. It's
Okay,
V,
sir.
not no. Don't change the alphabet here. Okay, using this method. This method is a little bit more complex than the earlier one. We are going to calculate what we call it penalty. We have a penalty. Let's figure out. Let's say if I were to use this 200, then I put 200 here. Is it okay? If I were to put 200 here, 200. Let's say it is your company, sister. Let's say Sister Sadia. If I were your staff, then try to analyze this. I put 200 here. Are you happy? Are you happy, sister?
Yeah, I guess.
Yes. I think you will be scolded.
No,
Sister Ayn said no. She will scold me. What are you doing? Can you see this one 15 ringgit? Can you
Yeah,
see
we
this
should
5
choose.
ringgit?
Yeah, choose the minimum.
If I were to use, if you are going to use this, I will deduct your salary. The sister very upset with the worker. So there is an element of penalty. Okay, let's look into. We have what we call it row penalty, and we have another one column penalty. How to calculate this penalty? We look at the lowest. Let's look into row penalty first. We are going to look at the row penalty, row by row, and then column by column. To calculate the row penalty, look at the lowest. Look into this row. Look at the lowest cost. Which one is the lowest cost? 9, 15, 5. First row.
5.
5 is the lowest cost. So we subtract 5 from the second lowest. What's the second lowest?
9.
9.
9.
So we have 4.
So 9 minus 5, is it?
4.
Subtract the lowest from the second lowest. So we will get 4. Oh,
4.
this one. This is how to calculate row penalty. 4. The second one, can someone say?
0.
Second low, huh? 0.
3, 3, 3.
3.
3. The lowest, subtract from the second lowest. 3. How about the
5.
third one? 5.
5.
Lowest, this is the second lowest, 5. Now you're faster. Let's calculate the column penalty. We just take this one lowest and second lowest. What do you get?
0.
0. Second one,
1,
1. Third one,
3.
3. Now, when it comes to penalty, you want to avoid highest penalty or lowest penalty?
Highest penalty.
You want to avoid highest penalty. So look at the penalty. This is, you can look all the penalty, both row penalty, column penalty, as well as the row penalty. Look at all this. 0, 1, 3, 4, 3, 5. Which one is the highest penalty?
5.
5.
5. 5 the highest penalty. 5 correspond to this row. 5 correspond to this row. And from this row, choose the lowest cost.
7.
In this row, what is the lowest cost?
7.
7. 7 is lowest cost. So we are going to use this route. We are going to use this route first. We are going to use this route to transport as many units as possible because this is the highest penalty, lowest cost. I repeat, look for the highest penalty, and then from here, we know very well it corresponds to this one. If the highest penalty is at the bottom, we look at the corresponding column. Here, we look at the corresponding row. And the lowest is 7. We have to transport as many units as possible along this route. So what's the maximum number of units you can transport from this route? Melaka require 170. Alusta can supply 220.
170.
170. 170. I think they don't need any more from Kota Baru and Johor Baru. Okay, done for this one. Then every step you have to recalculate the penalty. Every step, calculate the penalty. So now let's calculate the new penalty. Let's look into the row penalty for the first one. Every step. So this is done. Now let's calculate this one. We have only 2. Ignore this one. So those that have been used or not going to be used anymore, like this 9, 8, 7, not going to be used anymore, ignore this. So we ignore this. So we are going to use only two numbers, this one and this one. So row penalty for row number 1. Okay, kota baru row. What's the row
10.
penalty? 10. So the same thing here. This is used. So we are left with this one and this one. So what's the number?
13.
13. Then next one,
6.
6. Now look at the row column penalty here. No change, right? Where's the lowest? 5 minus 5, still 0. This one no need. Okay, how about this one?
Three.
Lowest. Okay, sister said, brother said 3. 3. What's the highest penalty?
13.
13.
13. 13. Now what should I do? Now I look at the corresponding cost along this row. This cost along this row.
Choose the lowest.
Then choose the lowest cost. Which one is lowest? 18 or 5?
5.
5. Now we try to transport as many units as possible along this route. JB can supply
130.
no 130. Everybody agree? 130?
Yes,
Agree.
Yes, everybody agree. So we don't need any more from the place Ipoh cannot supply there. Ignore this one. Now we are left with 1, 2, 3, 4. So you calculate again. This one the same, right? 15 minus 5, the same. 18 minus 12 is the same. How about this one? 12 minus 5. We cannot use is 7. 7. This one no need anymore. How about this one? No change, right? This one no change. What's the highest penalty?
10.
10. Now what? What should I do? Look at the corresponding row. Which route to use? KB Ipoh, KB Kuantan,
KB Kuantan.
KB Kuantan. Kuantan require 180. KB can supply up to 200. But Kuantan already have 130. So how many units to transport here?
50 more.
50.
50 more. Yeah, 50. Now what? No, we don't need this anymore. So we are left with these two. So now use our common sense. How many units to transport here? Again, 1. How many units to transport here?
150.
150. 150. How about this side?
50.
50. So this is our cost. Now getting less and less. So look into this. When we do the initial solution using northwest corner rule, we get 5860 initial solution. Use least cost method, 5630. Vogel's approximation method, 5240. It gives you the lowest. Why? Because of the penalty. Okay, we have another 40 minutes. I'm not sure whether we can make it or not for the next one. Okay, now we are done with the initial solutions. I think we should proceed. Rather, I think too early to release you from the class. You play Chongka. You know Chongka game?
Yes, sir. Right.
Play Chongka. Let's play Chongka. And then play Chongka. Who doesn't know Chongka game? We have this board. This board. Then we have last time we used pebbles or this cockle shells. And then I think this one sisters are playing. We have how many holes? 1, 2. I think there are 7 holes. 7 balls. Then opponent here. And how many pieces are required total normally? Those who play?
For each ball, it requires 7. So 7
7.
times 14.
So 98, right?
Yes.
About 98. So what we do is drop, take, drop, take, drop until something. Are you going to add from additional sources of pebbles when you take, drop, take, drop, take, drop, take? Like this is the take, and after that there's a drop, take, drop, take, drop. I don't know how to play this. In physics class, normally I carry this one and then we play, we have fun a little while and then we start playing the game. Do we need to add this from, if you are running short, do you need to add this pebbles? No, right? You just all this one until you cannot move on and you run out or until you are locked. Then you cannot, then I think one party will win, the other party will lose, right? We are not going to add this from additional source. So in economy, what do you call it? Exogenous, endogenous economy? I think we are not in business school. Okay, we are going to play this Chongka. This is Chongka, only I named this one Chongka. But the author of the book refer this as stepping stone method. So Modi and stepping stone method. So we are going to use what we call it modified distribution to find the optimal solution. What we did just now, the 3 method is just to find the initial solution. We are going to find the optimal solution using modified distributions. Then the condition, number of allocated cells, that means the cell that being used, m plus n minus 1, that means the number of sources, m, plus number of origin, minus 1, must equal number of destinations, 3. The number of use root or allocated cells must equal number of sources plus destination minus 1. Then we are going to find auxiliary index U and V. U correspond to row, V correspond to columns. And then we are going to calculate U and V using the cost C, I, J, C column I, row I, column J. And then we are going to search for U and V at the basic cells. Then after that, we are going to find improvement index. You call it Eij. And then the formula for Eij is the cos C of the row I, column J, minus U, this the auxiliary index, UV. Okay. This method is developed by this Chance and Cooper, also in 1954, long ago. Okay, let's move on. How much can we get? This is what we did just now using the northwest corner rule method. This is the initial solution. But is this solution optimal or not? We are not sure. Let's find out whether it's optimal or not. Okay, how to do it? So what we are going to do, we are going to find the auxiliary index, U. We are going to find UIVJ. We are going to find the index. We write here UIVJ, U. So how to find U? So this is the way to calculate the index. Where is it? Let's find the auxiliary index. How do we do? Okay, look at this one. Look at the basic cells. Okay, the cell that we use, we call it basic cells. These cells that is being used, we call it basic cells. This cells that we do not use, we call it non-basic cell. This one, basic, non-basic.
None.
This one, basic, non-basic cell.
Basic.
This one,
None.
none.
None. Basic. Basic.
Basic, okay. So basic. So we are going to look for the auxiliary index U and V. U1, U2, U3, V1, V2, V3. So what we are going to do is U row number 1 plus V number 1 equal this C11. C, that means the cost at row 1, column 1. Okay. Just to illustrate, we are U plus V equal to Cij. Okay, I go back. U1 plus V1 must equal C row 1, column 1. Okay, I repeat, U row 1 plus V row 1. I mean, these are the index of the U and V. This is we are going to find U row 1 plus V column 1 must equal the cost of at row 1 V1 for these basic cells. Okay. U1 plus V1 equals 5. U1 plus V1 equals 5. The next one is U1. We are going to start this one. U1 plus V2 equals, what is this number?
9.
9. So this is the second one. U1 plus V2 equals 9. Okay. Let's look at that next one. I say basic cell. Do we have to care about this one?
No.
No, this is
No.
non-basic. Say only basic cell. Next one, row. This row, we are going to find this one. So we have one basic cell. U row number 2 plus V column 2. That means U2 plus V2 equal
8.
8.
8.
U2 plus V2 equals 8. Okay. The same go for U3 V2 U3 V2 7. Okay, look at I think this is wrong.
So it's typo lah. U3 suppose this year.
Okay, I think you get the concept, right? The same thing is here. U3 V3 U3 V3. This is correct. This is U2. I think if in proper class, I can write this on the board. Now you have how many variables? I think better make some corrections here.
5.
Let me U3 5 variables. U1
6, I think.
6 variables. U1 U2 U3 V1 V2 V3. Then how many set of equations do we have?
5.
5. Can you solve simultaneously to find the value of U1 U2 U3 V1 V2 V3? Can we solve this? Any genius here?
No, sir, we cannot.
Cannot. If we have 6 set of equation, we can solve. Now we'll have 5. So since we cannot solve, we do some mathematical trick. Normally in practice, we let U1 equal 0. We let U1 equal 0. If U1 equals 0, can we solve the others? Can we find V1?
Yes.
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 What is V1?
5.
5. How about V2? Now you know U1. Can we? V2 is 9. Now, where are we? Now we know V2. Can we find U2?
Negative 1.
Negative 1.
Negative 1. What else? Now, can we find U? Now we know V2. Can we find U3?
Negative 2.
Negative 2.
Negative 2. Now can we find V3?
20.
We know U3.
20.
20. So let's write this. 0 minus 1 minus 2. 5, 9, 20 here. 0 minus 1 minus 2. Okay. 0 minus 1 minus 2. 5, 9, 20. 5, 9, 20. Okay, done with this one. The next stage, we are going to find what we call it improvement index. We are going to find improvement index. The improvement index, we are going to look at it from the non-basic cells. The improvement index is represented by E. E, row I, column J. So the formula is given by this one. Eij equal to cos minus U plus V. Or rewrite, if I were to rewrite, I write in this way. The cos on the non-basic cells minus U minus V. Okay. Then we are going to write this in the non-basic cell and then in bracket. Why in bracket? You want to differentiate this from the quantity. That means anything in bracket is index, not in bracket is the quantity transported. So let's do this. Take note. E minus equals C minus U minus V. I repeat, C minus U minus V. We are going to look at the improvement index for the non-basic cells. C, let's look at the first row. We are going to look into this index at this one. E row 1, column 3. We are going to C row 1, column 3 minus U row 1 minus the corresponding V column 3. Okay. 15 minus 0 minus 20. What do you get? Negative?
-5.
Negative 5. So we write here negative 5. We do the same here. Over here. C minus U minus the corresponding V. 5 minus negative 1 minus 5. What do you
1.
get?
1.
1.
1.
That's
So we
1.
put in bracket positive. Now here should be faster now. 18 minus negative 1 minus 20.
-1.
Negative 1. How about this one? 12 minus negative 2
9.
minus
9.
9. Now what? Now look at to this one. What it means here, this index, if we use the most negative, it will bring you the most improvement in terms of quantity, in terms of cost. So what we do, we will look into this one as a starting point. We are going to draw what we call it closed path. Closed path. We are going to draw a closed path. So in stepping stone method, we are going to draw what we call it a closed path. Start by selecting the most negative improvement index so that the cost will reduce rapidly. So draw a closed path that consists of a series of horizontal lines and vertical lines directed, vertical directed straight lines. That means a sequence of lines. So we start from the cell having the most negative improvement index, then traverse back to the starting point. Okay, what it means we will do later. The direction can be either clockwise or counterclockwise. That means if I were to draw the line, that means I can draw closed path, something like that. Not necessarily rectangle and close back. Or I can do anti-clockwise. Like that. This is what we call closed path. Then put positive sign at the starting point, and then in the subsequent cell, you put negative sign alternately. Add, minus. I put add, minus. Okay, let's play with it. What did I say just now? We are going to start the closed path by start from the most negative. What's the most negative index? Negative 5. So the most negative index is this one. We are going to put plus sign. We are going to add. That means we are going to add certain quantity in this root. This is non-basic cell. We are going to add some quantity, but we do not know how many units. Then we are going to draw closed path. Let's say this is the closed path. How to draw a closed path? From starting point, this one I do clockwise. Here, it travels from non-basic cell, move to the next basic cell. We cannot move here. Go to the next basic cell, then traverse again to the next basic cell. Then we are going with an intention of closing. If we are going to stop here, we cannot go diagonal. Then from here to here, we traverse here, then close. So our closed path will come down here, here, move up and down. And then here, we are going to add plus sign. And I did say just now, the plus, and then alternately here, negative sign. We put negative sign here. Then we draw another closed path, alternately, plus, minus, here, plus or minus. Let's say alternately,
Plus.
plus, plus. And then we are going to close, go up here. We have an intention of closing. So we have plus, minus, plus,
Minus.
minus. So now we can close. So this is what we call it, draw close path. And then theoretically, the founder of this one, they call it stepping stone method. They imagine all this closed path as if it is in a pond. As if it is in a pond. And then at the intersection here, there is a stepping stone in the pond. There's a stepping stone. So you're going to hop from this stone to this stone such that you don't fall into this pond. Okay, that's the theory behind it. But the point here, just look at the numbers. Now you see negative sign, sorry, positive sign, we are going to add. Here, negative sign, we are going to deduct some quantity from 200. Here, we are going to add some quantity to this 20 units. And here, we are going to deduct minus some quantity from 20. So now the question is, how many units are we going to deduct? Or how many units are we going to add here? Here is deduct. Let's say I deduct 200 units. Then I'm going to add 200 to 20. What would it be? If say let's say I deduct 200 from this cell. So here become nothing. Here nothing. Then here I will add 200 to 20. What will it be?
It will be over the demand.
Become 220, right?
Yes.
220. Then I have to deduct here. You say over. Then I have to deduct here. Deduct 200 from 20. What do you get?
Negative 180.
Negative 180. And then we cannot have negative pieces of pipes.
Yes.
No, if I were to deduct, so since it doesn't work, 200 will not work. Now let's say if I were to deduct 20, add here 20. Let's say I deduct 20 from 20, what will happen here? Nothing left. I add 20 here. From here is nothing, it's not 5. This is index for our starting point. Here become 20, right? From nothing become 20. Here deduct 20 from 200. What do you get?
180.
180. Yeah, if I were to add 20 to 20.
40.
40.
It makes sense, right?
Yes.
It makes sense. So what we do, let's say deduct 20 from 20. Don't put 0, put nothing. Then we are going to add 20 to nothing. It was nothing here. 20 to nothing, so become 20. Here, this one, we are going to deduct 20 from 200. Deduct 20 from 200. 180, right? Agree?
Yes.
Yes.
Now add 20 to 20. Add 20 to 20. 40.
40.
40. This one, no change. This one also no change because not affected by the closed path. Anything not affected by the closed path, no change. So this is the new solution, the new iterations. In Simplex, this is the new iterations. But is this optimal or not? To be optimal, just know the early one, all this C value must be greater or equal to 0. In this case, not optimal. That's why we have to draw closed path. Now, this is the, like in Simplex, this is the next iterations. We call this process, we call it, transportation simplex. What we did, linear programming simplex. Here, this, when you are using this table, we call it transportation simplex. Now the same thing, we have to find u. Now I don't show you, I don't show the method. The same method, u1 plus v1 equals 5, u1 plus v3 equals 15, and so on. After that, you put the first one equal to 0. So the once you put 0, you can solve this. Let's say this is what we get: 4, 3, 5, 4, 15. Okay, now we do together. Can you find the improvement index here? EIJ, what is the E? 9 minus U minus 4. What do you get again?
85. 5.
5. How about here? Now we look at the non-basic cell. Negative 4. Negative 4. Haziq say negative 4. How about this side? 18 minus 4 minus 15.
Negative 1.
Negative 1. And then here?
4.
4. Done. Is this solution optimal or not?
Not yet.
Not yet. Why?
Negative.
Because we have negative, so not optimal. So not optimal. To be optimal, all this improvement index must be greater or equal to 0. Now more shortcut. I straight away show this one. Okay. We start from the most index. We are going to draw close path. This is not optimal. We are going to start from the most negative by adding a number. That means starting from non-basic cell, move to basic cell. We cannot, after that, we cannot stop here. We stop to basic cell. Here, non-basic cell, we cannot stop, go to basic cell. But we want to come back here. From here, we cannot come back here because it's non-basic cell. So we have to stop here. Then we are coming back here. So we try to stop to here. This is basic cell. Then back here. So plus, draw arrow, minus, draw arrow, plus, draw arrow, minus, draw arrow, plus, draw arrow, minus, close path. Now we are going to add and deduct. Now let's look into, if I were to deduct 180, you'll have nothing. Here, if I were to deduct, what do I get? Deduct 180 from 130.
Negative 50.
Negative. It will not work. So if I were to deduct 130 here, and then I deduct 130 from 180,
50.
become still
50.
positive number 50, right? So now situation like this, what you do is look at the negative sign, choose the minimum number. Negative, negative, negative. Choose minimum number. What is the minimum? 130. So what we do, 130, here deduct, here become 130, here nothing, here 130, here 130 minus, 130 deduct from 180. That means take, you play
50.
congkak, take 150 from 130 from 180.
50
Okay,
leh.
50. And then you drop, you play congkak, you drop 130.
150.
Here, you play
Minus
congkak,
150.
you take 130, become 50. Here, you play congkak, drop 130 over 140. So this is your solution. Okay. This is the third iterations. Let's find U. Okay, let's find E quickly. 4, 3, 4. Optimal or not?
Yes.
Why optimal?
All positive.
0.
All the improvement index is greater than 0. Optimality achieved. All values of EIG improvement index is greater than 0. So this is what you did. This is what we did just now. If we are going to start from initial solution, you will get 5240. If we didn't do this one, if you were to do this, you will end up this one, 5240. If we use starting position as from VAM method, you will get optimal straight away. Because of the penalty. Okay, I think can I take a few more minutes of you, about 5 minutes to finish off? It's better to finish off than a little bit less. Okay.
Sure.
Okay, let's look into special case. Look at this one. Where's the total supply? Total supply?
550.
550. Total demand?
550.
550. Equal, right?
Yes.
Equal. Situation like this, we call it balance transportation problem. Balance. Okay. There are special cases, we call it unbalanced transportation problem. I mean, supply more than demand or demand more than supply. So let's look into this one. Let's say, now Melaka instead of 170, now 200. What is total supply? What is total demand?
580.
580. Total supply?
550.
Any difference?
30.
30. So 30 to make up 30. So what we do is we had to introduce what you call it dummy supply. Dummy supply. So here dummy supply. When you introduce dummy, the cost will be 0, 0, 0. Let's say we solve using northwest corner rule. So this is, I do quickly. This is what we get. What does it mean here? Dummy is fictitious supply. Non-existent. It's just for mathematical purpose only. It's non-existent. This is non-existent. This 30 unit doesn't exist. Because supplied by dummy. Now, Kuantan require 180. Does it get 180 Kuantan?
Yes.
Yes. Melaka require 200. Does it get 200, Melaka?
Yes.
20 plus 130 plus 50, yes. Ipoh require 200. Does Ipoh get 200?
No.
Why not?
Only 170. Dummy is not.
Only 170, because this is fictitious, a dummy, non-existent, only for this, for purpose of mathematics. So this unit is fictitious. That means Ipoh do not get this 130 unit. That means he had to get the pipe from somewhere else. You get the point? The concept of dummy.
Yes, sir.
Okay, let's look in another scenario. Now, over here, supply is 170. Initially 130, now 170. What's total supply?
590.
590. Total demand?
550.
So, what should we do? Balance it. If not balanced, we are going to balance it. What we did just now, non-balanced, we are balancing it. Let's balance it. How to balance? And introduce dummy also, right? How many units difference? How many units, brothers, sisters?
40.
40. 40. So we are going to introduce dummy demand. The same thing, cost is also 0. Let's say we solve this using northwest corner rule. Okay. Now, KB supply Melaka and Kuantan to Ipoh. JB supply Melaka and Ipoh. Alusta supply 180 to Ipoh. And then Alusta also supply to fictitious demand 40. What does it mean? That means this 40 doesn't go out from the factory. That means Alusta can supply to somewhere else, 40 units. He can supply to any other party. Okay. Done with this. There are situations when we have degeneracy. I mean, something doesn't function. Situation when m plus n minus 1, that means number of destination, number of source plus number of destination minus 1 does not equal the number of basic cells. So situation like this is not degenerate, but we can make it workable by introducing artificial variable, artificial flow, we call it. So artificial flow 0. So how to illustrate? Okay. Now m plus n minus 1. M is number of origin plus number of destination. That means 6 minus 1 is 5. Now number of basic cells only 4. It's not equal. So if you proceed to do the Modi method, it will not work. You have problem. So how to do this? You can introduce a zero flow. Zero flow. You can put anywhere on the non-basic cell, here, 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 here. So this 0 is to facilitate the process. That's why I say if there is nothing, we don't put 0, just put nothing. I think I said to take another few. Then alternate optimal solution can also happen when you do this E improvement index, one of them equals 0. If one of them equals 0, you can have more than one solution. You try to solve this 0 will move somewhere else. The solution is the same. I mean, the cost is the same. The root may be different, but the cost is the same. Another one, unacceptable root. So let's say KB and Ipoh not acceptable. So what we are going to do, we are going to put very expensive cost. I mean, very large magnitude of number. So instead of 15, this is unacceptable root. If there is pirate or whatever, communist there, we don't want, we feel not safe. Then we put very expensive cost, M. M large magnitude of cost. Then you proceed. Okay, done. You can use for other to do maximization, but we are not good to use this. All right. Class over. Thank you for sparing about 26, about 6 minutes for me. Okay, brother, any question? No question.
No, but
No. I think I do marathon today.
maybe we can revise the last part next class later. Can
Okay, no problem.
just revise a little.
As we try, I think we will. I think through practice, through our class practice, the next class will be practice. I think that will make you comprehend what is it.
Yes.
Okay. Okay. Can we conclude the class for now? I think we. Okay, we have to conclude. Okay, let's conclude our day with the recitation of Suratul As. Bismillahirrahmanirrahim. Thank you very much, brothers and sisters. See you next class. Thank you for Elo. Okay. Yeah, most welcome. Yeah, most welcome.
Thank you, sir.
You're welcome.
Thank you, sir.
Yeah, most welcome. Okay, welcome. Okay, I conclude the class now. I close. Assalamualaikum.